In this video presentation, we will discuss how to determine if an argument is valid or not. There are three types of compound proposition. The first is a compound proposition that is always true is called a tautology, whereas a compound proposition that is always false is called a contradiction or absurdity, whereas a compound proposition that is neither a tautology nor a contradiction is called a contingency. Now, for an argument to be valid, it has to be a tautology, meaning when you construct the truth table, the last column should have all values to be true. For example, let us try to check if this argument is valid. If you smoke, then you will have lung cancer. You have lung cancer, therefore you smoke. First, let us try to determine what are our propositions. So we let P be the proposition you smoke and Q be the proposition that you have lung cancer. Setting up the connectives, if you smoke, then you will have a lung cancer is a conditional statement, where if P, then Q. When you have lung cancer, that is your proposition Q, and your conclusion, therefore you smoke, is your proposition P. Now, combining the propositions and the connectives, we will now have the statement if P, then Q, and Q, then it's P. Now, let's try to construct the truth table. So first, create a column for the conditional statement if P, then Q. So that will be true, false, true, and true. Next, we have to get the conjunction between the third column and the second column. So using the conjunction rule, you'll have true, false, true, and then false. Lastly, you get the conditional statement of the fourth column and the first column. That would give you true, true, false, and true. Now, is this a valid argument? Since there is an entry in the last column that is false, then this argument is invalid. Let us check if this is a valid argument. If it rains non-stop, then UST will be flooded. If UST is flooded, then there will be no classes. It rains non-stop, then there will be no classes. So first, let us identify what are our propositions. So we let P be the proposition it rains non-stop. Let Q be the proposition UST will be flooded. And let R be the proposition that there are no classes. Let's set up our conditional statements. So for the first conditional statement, we will have if P, then Q. For the second conditional statement, we will have if Q, then R. Then for the last conditional statement, you will have if P, then R. Now let us set up the truth table. So you will have if P, then Q, and if Q, then R, then if P, then R. So first, let us create a column for the conditional statement if P, then Q. That will give us the following values. Next, let's set up the conditional statement if Q, then R. That will give us these values. The next step is to get the conjunction between the third column and the fifth column. That will give us these values. Next is to get the conditional statement if P then R will give us these values. And lastly, we get the conditional statement of the last two columns that will give us these values. Notice that all of the entries on the last column are true. Hence, this argument is valid.